So on this one, 32 is 2 times 2 times 2 times 2 times 2, right? There's 5 2's all together. So the fifth root of 32 is 2. Then we have to take that to the third power, so 2 to the third power is 8. So the first thing I tell you to do when there's a fraction is try to reduce the fraction. In this case, I can't. 16 over 9 are both not divisible by the same number. The second thing that we can do is to take the fourth root of one of those numbers. And I can take the fourth root of 16. That's 2. But I can't have a root in the denominator, so now I need to rationalize that denominator, right? 9 is 3 times 3. So I need 2 more 3's in order to rationalize the denominator. But when I multiply the top by those 3's, they're underneath the fourth root, right? So they need to be underneath the fourth root up here. Not outside, because a lot of you had 9 times 2 and got 18 on top. So now I get 2 and the fourth root of 9, but on the bottom I have 3. On the quiz that you had, remember I told you that if you're going to multiply them together, you really shouldn't multiply them together because you're going to factor it anyways to simplify it. So we're just going to factor it from here. So 4 is 2 times 2, and then 32 is 2 times 2 times 2 times 2 times 2, right? So there's 7 2's all together, and when I pull them out to the outside, I'm looking for groups of 4. So I have one set of 4 right there, so the 1, 2 goes on the outside, and then I have 3 2's left over. Don't forget the fourth root. So I get 2 times 2 times 2, which is 8. Do not forget that fourth root. This is a quiz, so if you forget these little numbers here in the roots, I'm going to take off points. So make sure you remember those roots. Okay, so I multiply with the same base, so I need to add the exponents. I get 2/5 plus 1/3, and then our common denominator is 15. So I got to multiply this side by 3 and this side by 5. So 3 times 2 is 6, plus 1 times 5 is 5, and then over 15. So when I add that together, I get 11 over 15. So that's my exponent, y to the 11 over 15th power. Another way you can add fractions, I don't like teaching it this way because you guys always forget to reduce fractions and such at the end. I'm talking at you. Some elementary school teachers will teach you to add fractions this way. So we multiply these two, and we multiply these two, and then we multiply across. Which is essentially what you're doing when you're finding a common denominator. It's just sort of a shortcut way to remember it. They usually call it like the butterfly method. I don't know. I guess it looks like a butterfly. Right? Yeah. But it's essentially the same thing. 3 times 2 is 6. 1 times 5 is 5. And then you multiply across and you get 15. The only problem with doing it this way is you guys do it for everything. Or it creates more work for you at the end when you have to reduce a fraction. Because usually it's bigger than what you need. Okay, when I have a power to a power, what are the exponents? We have to multiply them. So we get 1/3 times 3 over 5. And we can either multiply across and get 3 over 15, but then we have to reduce that and get 1/5. Or we can cross cancel because it's multiplication and we still get 1/5, right? So we get a to the 1/5 power. So we're looking for sets of 4 in there in the radical. So 32 is 2 times 2 times 2 times 2 times 2, right? So I have one set of 2's and then one underneath. Don't forget the fourth root there. If we look at the x's, I have 6 x's, so I have one set of x's I can move to the outside, and then I have 2 left over. If we look at the y's, I have 9 y's, so I have 2 set of 4's, and then I have 1 left over. Right? So I end up with this. This problem right here asks us to add them together, right? When we add them together, we just combine like terms. So I don't have any x cubes except for that 1 3x cube. I can't do anything with it. But with the x to the 1/2 power, I have 2 of them. So when I combine that together, I get plus 4x to the 1/2 power. Now for the domain part. In the video, I told you that the only time you have to be worried about the domain is when there is an even root or when there's an x in the denominator. Because when we try to find the domain, we're trying to find all the values for x that we can plug in there to get a real answer. So we can't have any imaginary numbers, and we can't have anything that's undefined. And as far as what we've done so far, these are the only two situations when I get an imaginary number or I get something that's undefined. So if we look at this, 4x cubed plus 4x to the 1/2 power, this right here, this 1/2 power, that's an even root, right? A root is square root, third root, fourth root, and that's an even root because the number 2 is even. So we're thinking about even roots, and if I want to make sure that it's a real number, I can't have any imaginary numbers. So what kind of numbers do I plug in for x and get imaginary numbers? Negative numbers. I can't have imaginary numbers, so we have to take out all the negative numbers. So my domain is going to be all, we could say it a couple of different ways. We could say all reals except negatives. We could say the book says all non-negative numbers. That means the same thing. Or another way to say it is x has to be greater than or equal to 0. Because it can't be 0, the square root of 0 is 0, so we can include that this time. So either one, any one of those three ways is the way to write the domain for that. This problem is asking us to subtract f of x and g of x. So I need to subtract 5x to the 1/2 from 3x to the third minus x to the 1/2. So if I combine like terms, I get 3x to the third minus 6x to the 1/2 power. Remember, when I find the domain, anytime I have an even root, which I have here, I have an exponent of 1/2, I get all non-negative numbers. So with this one, I am multiplying. I'm taking that 3x to the third minus x to the 1/2, and I'm multiplying it to x to, or 5x to the 1/2. Okay, so if I'm not just multiplying that 5x to the 1/2 times that last term, I'm multiplying it times all of f of x. So in this case, I have to distribute, right?
Oh my God.
When I distribute, 3 times 5 is 15, and then x to the third times x to the 1/2, I add the exponents, and I get 3 plus 1/2, which is 3 1/2, which is 7/2. Then I do the same thing with the other one, so I get minus 5. X to the 1/2 times x to the 1/2 is 1/2 plus 1/2, which is just 1.
So you're just adding.
So I get this.
So you're just adding.
Yes, you just add the exponents. Need the domain for that thing. So that thing doesn't have an x in the denominator, but it does have an even root. So in this case, again, we need the all. You could put all non-negative numbers.
Isn't it? Negative. Is it that? Negative. To all of them?
No.
That don't have negative?
This one asks us to divide, so I take that f of x and I divide it by the g of x. And then I reduce if I can, but in this case, I can't reduce. I have a subtraction between the 3x to the third minus x to the 1/2. I can't reduce, it's not multiplication. Nothing moves around the fraction, there's no negative exponents, none of that. So I have to leave it just like this. The domain on this one, I have a even root, so I definitely can't have any negative x's, right? Negative numbers for x. But in this case, I also have an x in the denominator. And I can't have, what is the one number that I cannot have in the denominator? 0. We cannot have 0 in the denominator, right? So in this case, I can't have negative numbers, and I also can't have 0. So x has to be greater than 0 in this case for the domain. This problem is asking me to do the composition of f of g of x. So I need to take f of x and take out the x and plug in g of x. And then simplify. So because the 2x plus 3 has an exponent of a negative 2, that's got to go on the bottom. So I get 5 over 2x plus 3 squared. And then it asks me to state the domain. So remember, when there is an x in the denominator, which I have here, let's make it a different color. I have an x in the denominator right here. That denominator cannot equal 0. We cannot have 0 in the denominator. So in order to figure out or find out when that thing is 0, I have to take 2x plus 3, set it equal to 0 to figure out what x is. So subtract 3, and then divide by 2. So in this case, my domain is all real numbers. Let's erase that right there. Oh, I can't. Let's try it again. Oh, it won't let me do it. Okay. So all real numbers except, here, let's write it over here. All real numbers except negative 3 over 2. So x can be any number I want except for negative 3 over 2, because negative 3 over 2 will make that thing 0, and we cannot have that. This problem is asking us to do the composition of g of f of x. So I take g, and I take out x, and I plug in f of x. And then I simplify. So I need to multiply this together, and I get 10x to the negative 2 plus 3. And then I have a negative exponent on the x, only on the x, so that's got to move down to the denominator. And I end up with this. And remember that I have not showed you how to simplify this yet, so you can leave it like that. And the domain, remember, we can't have 0 in the denominator, so x is all real numbers except 0, because this thing can't be 0. Remember from 6.4, the way to verify whether things are inverses or not is I take 1 and plug that into the x for the other one. So we get 5 parentheses x minus 4 over 5 plus 4. And then I simplify it. So 5 over 1 and x minus 4 over 5, the 5's will cancel, and I get x minus 4 plus 4, and then negative 4 plus 4 is 0, so I end up with just x. So I have verified that those two are inverses of each other. If I'm asked to find the inverse, and I have to write them two ways, I have to switch the x and the y and solve for y. So I add 7, and I get x plus 7 equals 6y, and then divide by 6, and I end up with x plus 7 over 6. So the inverse of y, remember that little negative 1 on top on the exponent just means the inverse of y, is either x plus 7 over 6, or remember I have to write it in two ways, so it is also 1/6 x, or x over 6 plus 7 over 6. I will ask you to write it both ways on the test.